All right. Just because for some reason when I go really long, it like tells me I can't or something. All right. Okay. Give me a second here. I gotta figure out something.
We have 25 minutes.
Okay. Here we go. If a compound, don't write it, just try and figure it out, containing CHO is completely combusted.
I forgot how to do these.
I just do the steps in the wrong order.
I
never know if yours was divided by the wrong one every single time.
I just do general midterm.
Yeah.
Which of the following,
Oh, it's multiple.
well, I'm trying here, could be the formula?
But you
the
said
empirical.
on the midterm it's multiple choice.
Yeah, I'm trying to just really go over what we need for it. It's the same concept though. I don't want to spend the next 20 minutes doing one of those long ones. We don't have time for that. That's not efficient. Be the empirical formula. You still need to know how to do the big long equation just quickly on a multiple choice question.
Great.
All right. Oh, wait. Complete combusted. I forgot to add what you need to know.
Yeah.
Complete combusted. Sorry. Producing or giving. We'll say producing. 88 grams of CO2 and 63 grams of H2O. Yeah.
Oh no, it's just CH.
Wait, it's also producing 88 grams of CO2, 63 grams of, and some
Oh wait,
NO2.
because it's multiple choice.
Okay.
Okay, cool.
So go ahead, start working while I'm thinking what the best choices to give you are.
So there's just a random NO2.
45 plus.
Yep. Welcome to the AP test.
No, you're gonna check.
Welcome to failing. I can't comprehend this.
3.5. How am I supposed to get that?
What is
What
that? My brain is legit jelly.
Would it have numbers this hard on?
Yeah. No calculator. Remember, no
I
calculator.
don't know how to do long division.
You don't need to do long division. No, you don't.
63 divided by 18.
It's this.
I'm crying. Divided by 48.
I don't know how to do these.
Just, will we cheat just this one?
No.
You know it's bad when Kira asked it.
Oh, that was wrong. Okay, let's go.
Okay.
It's fine.
I'm gonna be up on the roof for a minute. I see me go by the window.
No, wait.
Where'd the end come from?
NO2.
Some NO2.
Wait a second.
Jesus Christ.
What?
What?
I did it wrong.
What does it even mean?
It's so bad.
Oh.
So here's what has to happen for you to do well in the midterm and on the AP test. You have to gain some confidence.
I don't have any fun.
Yes, you do. All of you are smart enough and capable enough. That's why you're here. So when you get to this question, I need you to say to yourself, for example, this question, I can figure this out. Don't just, think I can't do this and then laugh it off or whatever. Because then you can't do that on the test. Right now it's different, we're in review class. But during the test you gotta do the best you can. So you guys know how to convert to moles. That's always the first step.
I don't think any of those are the answer. Oh, okay.
So yeah, no, one of them's there. One of them's the answer. So
Wait, you said.
let's just do it together.
Wait,
88 grams of
you
CO2.
said the compound is CH and O, but those are all CH and N.
Oh, that's bad habit.
That's why I'm
Yeah, I was thinking, I don't
That's
know.
That was most questions say CHO. Sorry. All right, so hold on. I just want to get these lights back on. I think it makes it easier to see. I guess it doesn't matter. All right, so how many moles of CO2 do we have? 2 moles of CO2. 2 moles. If all of the carbon is combusted completely, then 2 moles are what you started with. Okay. So all that is the moles of carbon. The 2.
Yes.
Okay.
So it's not 3 or 1, possibly.
Probably not.
Good.
Okay. Good. Now, see you, Kira. You'll be here tomorrow, right? I'll see you tomorrow, obviously.
Yeah.
Okay. She sounded so excited. How many moles of water is that? 3.5. You need to be able to do that on paper or in your head. You can't use a calculator.
Yeah, I should
Okay.
do that.
Because the molar mass is 18. So there's 1 mole in 18 grams. So 2 moles, right, 3 moles is 54. 54 plus 9 is 63. So half of 18 is 9, that's half a mole. So 3.5 moles. Or you can just do 63 divided by 18. If that makes more sense to you.
All right,
That's how you
that makes that's
all right.
alright. That's easier to
You'd be better
comprehend.
off multiplying and then guessing instead of doing long division because then you have to multiply anyway to
So
figure out
this-
control.
This gives you 3.5 moles of H2O. We need moles of H.
So would you
Take out
divide
the
that?
2O.
So times 2,
Times it by 2. Why, Marcy?
because there's 2 H's
Yeah.
for every H2O.
Okay.
So it's
I
not
got that.
grouped together.
Well, it is.
1 mole of marker is 1 mole of cat.
I know, but I'm thinking like H2 is its own
That's one of my
thing,
favorite
that's
things I've ever said.
why.
So if you have 1 mole of H2O, it's 2 moles of H.
Okay.
So if you have 3.5 moles of H2O, that's 7 moles of H. Because there's two H's for every 1 of
But you just
H2O.
said there was some in.
So it's
How many in the
Well, it doesn't matter. N's always 1, so I don't think it.
Answer's
yeah,
4.
N is always-
Answer's 4. Because you have 7 moles.
Oh, yeah, because they're all.
You have 7 moles of H, 2 moles of C. That's the only one that would match that 7 to 2 ratio or 2 to 7 ratio.
Alright.
Oh, yeah, because it was.
So for empirical,
I get it.
empirical determination, remember you find the moles, then divide by the lowest number. But in this problem, they don't give you enough information to actually do the full problem. So in a multiple choice, you would say, oh, well, I know there's 2 and 7. The only one that makes sense is that.
Okay, yeah.
Okay. Any other specific questions before I move on here?
I
Something
don't
else?
know what I don't know.
All right. Well, that was a good question.
Either one.
So if you have a sample of gases, there's a decent amount of pressure questions. So if you have a sample of gases, which ones move faster? Which ones move slower? Smaller move faster. Larger ones move slower. Good. That's diffusion, basically, or that's just basically even if they're at the same temperature. Now there's equations for that, but you're not going to have to calculate anything. Just explain and understand that the big ones have larger molar mass. That was that 3RT over molar mass. That gives you the URMS. Remember that?
Oh, I forgot that.
It,
I remember.
it's kind of irrelevant as far as the calculation. Just understand that the molar mass dictates the molecular speed. Now, if you have a mixture of gases, how do you find the partial pressures?
P1 equals X, it's sub 1, P1 not.
Right, and that's in your equation sheet, but the concept there is the mole fraction, so part over whole. So 1 mole, the one gas, moles of one gas over moles of everybody times the total pressure. So, right, so if you take, if you have 1 mole of neon and the total moles in the container is 10, it's 1 over 10. That'd be the mole fraction for neon, let's say. And then multiply by the total pressure. That's partial pressure. But what if you know the partial pressures of each gas? So let's say you have, what? I'm supposed to be gone. Just call me. Hold that thought. What was I going to roll? Individual containers. Hello? Hey. Oh, I didn't know that.
One.
I didn't even look at the thing. Is that because of my classes that are here, obviously?
Hello.
Okay. Fine, sure. Okay, thanks. Bye. Alright, let's say you have 3 containers, each with their own type of gas. Neon, nitrogen, and oxygen, let's say. So you have 3 containers. 1, 2, 3. So let's say this is nitrogen, neon, oxygen. I don't remember what I just said. And then let's say you have a larger container, and you know some information about these, and then you combine them to that larger container. Will the pressure change? So,
Are you supposed to pretend they don't interact with each other?
well, yes, but the pressure, so let's say these are 1 liter containers, and this is a 3 liter container.
So you just add them together, right?
So if I wanted to know the total pressure in here, I would just add up the individual pressures. Right. So that's what you're getting at. So if nitrogen had, if this was 2 ATM, let's say, 2 ATM, this was 1.5, and this is 1, and you put them in there, you would just add those 3 numbers because they do act as if the other ones aren't there. So they're bouncing around basically the same. But remember, this is a larger container. So what does that mean? So this, let's say, is a 1 liter container with a pressure of 1 ATM. If you put oxygen gas in a larger container, will the pressure decrease? It should, right? So just, again, without getting into specific details, again, the concepts will help you. So if you understand the concept, whatever they ask, you can figure out. So just remember, partial pressure, Dalton's law of partial pressure, if you mix these together, you can add their individual pressures for the total, but remember, if the size of the container starts to change, then that's going to change the pressure, right? Your volume gets bigger, your pressure is going to decrease because there's more space.
So then you would do like P1, V1 over P1.
Yeah, or PV equals nRT. I don't think you have to use P1, V1 over T1 at all, but
Okay.
PV equals nRT is on there. Yeah, just keep that in mind.
PV pressure on
If you heat these up, do they start moving faster?
0 A21.
Yeah, all that's on your equation sheet. Yeah, if you heat these up, the gas particles start moving faster, pressure will increase. So there are a few questions that you have to understand dispersion forces and what makes them stronger or weaker. I put that on the equation sheet or the review sheet. So you guys remember?
Contact area?
Yeah. So if you have a,
And like
there
how
might
big
be a
is-
question on the midterm about that. So if you have a short chain and then a longer chain, and there's a discrepancy in the boiling points, the longer chain should have stronger forces
Oh, yeah.
because there's more surface area. Okay. What's another one? Besides, so let's say the longer chain maybe
Molar
had a
mass.
smaller molar mass, right?
Yeah.
So the AP test is going to try and get you, you know.
So which one is precedence?
Well, if they give you data, you're going to
Okay.
have to figure it out, right?
What?
If it's obviously not the molar mass, then look at something else. Does that make sense? Molar mass, surface area, or surface contact, number of electrons, polarizability.
That's the one, I don't know.
More electrons means more
Okay.
polarizable, meaning you can have those temporary dipoles can be formed easier if you have more electrons moving around. Lattice energy, what's that? Good one.
In between.
Lattice structure or ionic?
That made me laugh.
Lattice structure is like an ionic.
He says good one, and Bree just keeps doing this. I don't know what that means. What does that mean?
I don't know.
Lattice energy only applies to ionic compounds. Coulombic interactions. MgO has much higher lattice energy than NaCl. Why? What's the two things that affect how strong the lattice energy? Lattice energy is the energy required to dissociate 1 mole of an ionic compound. So how to rip that apart?
Definitely charge.
The magnitude, right, +2 or -2, +1, minus. So this has +2, -2, that's a stronger attraction, +1, -1, and then the other one's actually more important. Right, the ionic radius. So Mg + 2 is smaller than Na + 1 because Mg + 2 has 12 protons pulling it in close. They both have 10 electrons, but Mg has more protons. So this is not only a higher charge, but more concentrated because it's a smaller radius. Same thing with O versus Cl. So these two ions can get really close together, and their magnitude is greater. There's a couple questions about that concept. Let's see here. There's a couple things you don't really need me, but because you can look them up online or in the book. But while we're here, I might as well talk about them. So the Maxwell-Boltzmann distribution. Yeah. So just make sure you understand that it's going to look something like this. All right, here's your number of molecules. This is your energy? I'm losing my mind right now. No, it's not temperature.
Boy, that's good.
A little bit of a long
If you took an AP
That's a
test,
good
you think you get a 5 on it.
You
Yes.
can take the midterm with us.
I was
or
gonna
you
ask.
can take them all.
Yeah.
Because we
You,
don't know chemistry. We only
Can you
know
take my
basic
midterm
chemistry.
for me?
And it's hard for us.
But if it makes you feel better, there is no way I would get 100 on it. No way. I would make mistakes. This stuff is hard.
That doesn't make
Yeah, where's these clowns when you need them?
You make mistakes, I'm definitely going to make
I'm gonna be safe for a minute. Mr. Lotus would make a mistake.
There you go. You would get a perfect score.
Teamwork.
Where is this thing?
And then you're forced to take the chemistry class. Why are you AP Chem?
Yeah, it's either energy or speed.
Oh, isn't it like average?
Yeah, it's either energy or speed.
so like
Yeah, energy. Yeah, energy's good enough. All right. So if this is T1, let's say, and T2, we're gonna draw T2, but it's hotter, higher temp. So let's say T1 is 200K. Let's say T2 is 500K.
It'd be more
Right. So it'd be more and shifted over here as well. Okay. Shifted over. Why would it be shifted over?
Higher energy.
Right. Okay. What if it was? So that's T2. What if T3? Let's say 500. What if T3 now we cool it down to 50K? Right, and it would be shifted left. Okay. So something like that. Well, not like that. Okay. So that would be 50K. All right. So it'd be more rounded. Does that make sense? So the slower it is, right? The slower the particles, the less collisions there are. So they're not spreading their energy out. So there's going to be more particles moving at that one specific energy. There's less transfer of energy. If they're hotter, warmer, moving faster, there's more collisions. So it's more spread out. So it starts to get flatter. So it isn't all concentrated at one. Plus it shifts because there's more energy. Makes sense, hopefully. Yeah, actually, when I was going through these questions here, picking them out for the midterm, I was basically taking them or doing the questions before picking them and before looking at the answers. And there's a couple I got wrong, and one I got wrong because I totally missed the little trick that they threw in there where the container size changed.
And you put that on your
Yep,
Cool.
I did.
Great.
Yeah.
Challenges are good.
It's not easy.
You're good. Sample's fine if he's always like, okay.
Paper chromatography. Paper chromatography.
Yes.
Well, how does it work?
It's,
You need a solvent that you dip the paper in.
And it separates depending on how attractive it is to the solvent.
Yes.
It moves very quickly.
Right. So if you have,
why are you crying?
I cry a lot.
Okay, you do this and you have, I don't know, some stuff up here, some stuff down here. So we have A, we have B. What does that mean?
B is more attracted to the solvent.
No,
And
A is.
A is more attracted to the paper.
Oh wait, yeah. I'm
Right?
right.
No? Am I wrong? I'm wrong.
I don't know.
I think.
I just think.
I think that B is more attractive to the solvent. And A is more
Wouldn't A
attractive
be
to the
more
paper.
attracted to the solvent because it might fit there with it?
Yeah, no, but it's not. Yeah, but everyone else wanted
That makes sense. I
No,
agree.
it's not.
on the paper.
Which one's more attracted to the paper?
I think
A.
B.
C.
It's definitely A.
I don't think it is.
I don't think it is.
Where are these little blobs coming from? Down here, right? The solvent.
Yeah.
Okay. So if they're coming from here, and if this is really attracted to the paper, as soon as it touches the paper, isn't it going to want to stay right there?
Yeah.
Yeah.
Yeah, so this is more attracted to the paper.
Okay, cool.
But does that explanation make
Yes,
sense? That
I
if as soon as it starts to touch the paper, it's going to start to have those attractions, so it's not going to get very far because it's going to stay attracted. Does that make sense?
Yeah. Is that the same as when you drew the lines with the blue marker and
That might have been
separated?
upside down. Oh yeah.
Is that okay?
Yeah. Yeah.
Yes, I know.
Yeah. Do you remember this graph? Or something like that.
Smart for one.
I think I should probably just put this one up.
Yeah, I don't know.
Oh, I don't want the video. I don't want the finger. Okay, you know what? I can label it.
way to lift yourself up is right there.
There's still so many bananas.
Okay, energy, internuclear distance. Okay. 0, positive, negative. Okay. You remember seeing this for hydrogen gas?
They want to be the perfect distance.
Right, so if they're here, they're too close together. If they're here, they're too far apart. Here, they're just right. So on this, you just need to understand, okay, yeah, you've seen it, you understand what that dip is all about. So the energy dips because it's, why is it dipping?
Stable.
Stable,
Yes.
right, okay. So just, I want to refresh your memory, okay, on that. Oh, I put this on the review sheet, but I'm going to explain a little bit. There is a question where I give you a series of reactions. There's like 6 the AP test. This question took me a little while to do because I was like, wow, this is tricky, but it actually isn't that hard. It's easier for me now, obviously, because I looked at it and know the answers. But there's 6 reactions, and there's one part of this question where some student came up with a procedure to separate or isolate one compound from all of these reactions. And the student gives you like the first 2 steps, you have to fill in the next 3 or 4.
Is this on the midterm?
Yeah.
Alright, well.
But it's not anything you've never done. It's
I feel
no, short answer.
discriminated against because this student's experiment's on it and not mine.
Right. I just want to tell you there's one word, and I put it right on your review sheet. It says filtrate. So when you filter something, you get the solid, and then you have the filtrate. What's that?
Non-solid.
The solution left over, right? Yeah. So I just want to, if you understand that, it makes the question much easier.
Where in the world do we see filtrate?
Almost at the bottom of the.
Oh, there it is. The word filtrate. There it is.
So if you filter something out and you get the solid's gone, you take that solution, that's called the filtrate. So that solution you can now continue to do whatever you need to do. So just remember that. But yeah, if you want to separate ions from each other, what could you do? I think I put that in.
Something that only one of them forms an insoluble compound.
See, there you go. You guys already know. Well, she said it, but I'm assuming you guys are thinking it. Yeah, if you have 2 ions like silver and sodium.
Silver nitrate.
What could you add to precipitate it? Not nitrate, right?
Oh, wait, what are they?
Water? Is that what you said? Water?
Hydroxide.
You got put them in water, but then they both.
That's salt.
Let's say you have a solution of silver ions and sodium ions.
Okay.
I want to precipitate. I want to get those ions separate from each other.
Could you put like potassium chloride?
Hydroxide is insoluble in most cases.
Or KOH.
Sort of.
Yeah, could you put
According to that
potassium chloride?
Yep, that would work. AgCl
AgCl.
precipitates. AgOH, I think it does. Yes, it does precipitate. Yep, that would work too. Okay. So then what would you do? So you added your
Which one are you trying to get?
yes.
Because it was filtered.
Okay, filter it, and you get
Whatever is left.
Silver.
silver hydroxide or silver chloride, right? Okay, good. Then your filtrate will still have sodium ions. But if the lab or the test question gave you a reaction to get the Na out, then you would say, all right, just use that reaction. I'm trying to help you without giving you the whole question. You know way more than you think, trust me. So you get stressed and overwhelmed, I get it. But if you really just try and take one question at a time, that helps. Instead, let's say there's like 2 or 3 in a row, you're like, I don't know how to do these. It's gonna kind of hurt you if you keep thinking about them as you're taking the test. Yeah, one at a time.
Why would it make silver chloride instead of sodium chloride? Like, how would you distinguish? Like, why would you?
Oh, because silver chloride is insoluble. So if you have silver and if you have Ag plus Cl minus near each other, they will combine and form an insoluble solid. Yeah.
Okay.
Well, but there's a better reason. It's because the KSP for AgCl is ridiculously small. You don't know what that means yet. It's not on the midterm. Wait, yes it is.
What?
I was gonna wait till the day of the midterm to tell you this, but I'll tell you now. There is one question on the. Hold on.
I'm sorry.
Want to take this outside? There's one question on the midterm that I'm just straight up giving you the answer to, because there is a series of questions and one of your short answers. So there's multiple parts, and this part you need this answer to do the next 3, but you know how to do the next 3. You just need that one answer. So I'm going to give you an answer based on KSP, and that's based on equilibrium. We haven't gotten there yet, so we will next week actually learn about that.
At least I know I'm getting a part of a question.
Yeah, you're getting that one. I'm getting
one
that.
part
You're
of
getting
one
that.
question right.
Right.
I
Oh
will
no,
not
you
get
did
a
that.
0.
That empirical question.
It's the same question.
No, but it's very similar.
Not a guarantee I get that.
All right. What else? What else? Went over that. Went over that. All right. On the review sheet, it says there's a tough question on absorption spectra. I got this right, but remember I told you I was kind of doing this as I was putting it together. I got it right, but I narrowed it down to 2 questions, and probably just because I've been teaching for a while, the one made a little more sense, but I didn't really know why. It just felt right. So kind of, I guess I'm saying I got lucky. So it's a hard question, and the reason it's hard, and I think it's a cheap shot, is because nowhere in this thing, that AP Bible that I really try and stick to, because that's what they tell me is on the test, nowhere in there is this question. It doesn't match up with anything. So I got pretty irritated. But you have to understand that there will be questions on the AP test this year that you're going to swear we didn't learn, or we only learned part of what they're talking about. So that's going to happen. I literally can't cover every little thing. I try as hard as I can, but but I will say, 2 years ago, all the kids who took it said, yeah, there were questions that they didn't know how to do, but it was on material that they remember learning. So as long as we have that there's something in the question that you do understand, that's the best we can do. So anyways, just keep that in mind. That's why this is a hard class. Back to this question. So there is one on absorption spectra. I said look up in your book or online how different regions of the spectrum, electromagnetic spectrum, are produced. Not all types of waves are produced from electrons moving from one energy level to another. So I know that. Some of you may know that, but I didn't really spell it out in class when we went over this. For example, infrared. That isn't produced because electrons are jumping around. I mean, it is, but it also is to do with what? What is infrared? Heat. It's heat and energy. And what causes that? Well, temperature measures it.
Average kinetic energy.
Okay, so the average kinetic energy is the definition of temperature.
Yeah.
So that's how you measure heat. Movement. The faster things move,
More heat.
usually the more energy involved, right? Right. So remember that. Faster things move, the more energy. Okay. Now, the other part of that, there's another part of the spectrum that isn't produced from electrons falling and jumping and falling.
Guy's not here about this.
What's that?
Guy's not here about this.
Is it?
Can I drop out now?
No. It's one question. So some parts of the spectrum are due to molecular rotation, which is different than molecular movement or vibration.
Like the pi bond thing where you can't rotate it because it breaks.
Sort of, yeah. So I would look into that. I would look into that. So I'm not going to give you the answer to the question. The good news is I think there's parts to that question, choices you can eliminate. I would think. All right.
So it's not short answer, it's multiple choice?
That one question I was talking about is multiple choice.
Oh.
See you later.
Review Beer's law. A equals ABC.
I'm pretty familiar with beer.
Oh. Basically out of time.
Molar absolute.
There was one question I did want to do with you. All right, let me just go through the concept quick.
I'm pretty sure we have time to work
Why do people call you Bean again?
I
It
have
just
no
happened
idea.
one day.
Sixth grade, I think it's
It
started.
just stuck.
Yeah.
Just
I like
stuck.
Laura Griffin.
I know your other nickname stuck.
I got it.
You had a lot of.
I ate a lot.
It happens. Just that.
I prefer not to think about it. That one. Yeah. She did that too. I don't know.
I saw that.
Hold on a
She's
second
the most
here.
creative.
Oh, man. Follow me.
Just this last thing here I want to talk about.
CR.
More creative than the rest of us.
Yeah.
Why are you
Yeah,
like
is it?
coming up with-
Swear. Do you need a
I need some
Nothing
carrots.
is as ridiculous as Betty Spaghetti.
Finish the line. I'll finish the line. I'll start it.
People forgot about that.
Completely forgot about that.
Slightly less hard.
Nobody calls it, but mine was worse than Betty Spaghetti.
Was that true?
Yeah, that's true.
Because her curly hair.
I can't remember if it was a mixture of Earl and Slade.
Yeah, it was Earl.
Combination.
I wish I was.
Because Earl sat behind me.
Okay. There is one question like this. We did do this stuff earlier in the year. You have a mixture of two compounds. You know the mass of that mixture. Through some sort of lab process or whatever, you get 2 grams of NaCl. So you know the mass of just the NaCl. Here's your mixture. Okay? You don't know the mass of this, but you do know the total mass of the mixture. You know you have 2 grams of that. How do you calculate the percent of just the Na? So let's just think for a couple minutes. I'm going to pack it up here.
We never use sodium. I'm just those.
Calculate percent.
The percent mass of it in the mixture?
Yeah.
77.
I can only change this to moles of sodium chloride.
Okay.
And then that's that many moles of sodium, or that active grams divided by 5.
Right.
Which I don't know.
Perfect.
Is that right?
Done. Yep. So here's the concept. If you find moles of NaCl, now this is an easier version of the one you're gonna have to do, but it's the same exact, yes, just like that. So if you have moles of NaCl, which is, Marcy?
0.0345.
0.345 moles. So that's of NaCl, that's the same as moles of Na. But let's just say on the test, it isn't a 1-to-1 ratio. How would you fix that? Let's say it was Na2Cl. Let's say there was a 2 there. What would we have to do to that number? Because I want moles of Na. If there was Na2Cl, let's just say there was a 2 there. What would I do to that number? Right, we'd have to double that number because there would be 2 moles of Na for every 1 of NaCl. So just keep that in mind. So this is how many moles of NaCl, which is moles of Na. Now you use 22.9 or 23 grams. Convert this into grams of Na. So 0.793
Yeah.
grams of Na divided by 5, that gives you your percent times 100.
Oh, so I did.
So we did that earlier in the year. It is kind of a tricky concept, but remember, we're always finding moles first. That's kind of the rule with those. We just kind of went over a lot, so that was good. That was good. Good work, everybody.